Hello students, uh, today we are going to discuss about one of the group of drugs called as macrolides and lincosamides. So we are going to discuss about macrolides, macrolides and lincosamides. Okay. So before starting macrolides and lincosamides, I want to brush up the mechanism of action of inhibition of protein synthesis by these group of drugs. So we'll see how the protein synthesis is inhibited. Okay. Okay. So macrolides, not only macrolides and lincosamides. So previously, the broad spectrum antibiotics like tetracyclines and chloramphenicol and Acidus class of aminoglycosides. So all these things will inhibit protein synthesis. To understand the inhibition of protein synthesis, so we have to understand how the proteins are synthesized. Okay. So proteins, yeah, as you know, proteins are synthesized by ribosomes, mRNA, and this is the mRNA template. Okay. And we know ribosomes have two subunits, the large subunit and another is small subunit. Okay. So in bacteria this is 50S subunit and this is 30S subunit. This S is nothing but it's a sedimentation velocity in a ultracentrifuge, and this is nothing but Schwitzberg unit. Okay. S is nothing but Schwitzberg unit. Okay. So we have the bigger subunit as well as smaller subunits. This is in bacteria. What about in human beings? In human beings, it is 60S and 40S. That's the reason when we take these drugs, they don't affect our protein synthesis. Okay. So this is in humans. Now coming back to the bacterial ribosome. See, this mRNA, it contains codons, and they are complementary to which the amino acids will be placed in the protons. So in proteins. Okay. So in bacteria we have discussed these 50S and 30S ribosomes are there, ribosome subunits are there. So now there are two sites here. First site is P site and the next site is A site. Okay. So P stands for peptidyl site. Okay. And this A stands for acceptor site. So we have to remember that tRNA will take and come the complementary codon, and it will get attached at the only at the acceptor site, that is A site. You can remember this P as in Hindi we call it as pehla, means first, and A is after in English. First in Hindi, next in English. A is after, so it comes after this one. So now coming to now we'll see what happens exactly during protein synthesis. So this is your P site and this is your A site. Okay. So for example, at P site we will consider like already there are 3 amino acids attached to the P site. Okay. We'll take an example, and the new amino acid is bought by tRNA and it gets attached at the A site. Okay. Now what happens is Now these are complementary. Okay, these are all complementary. The same. And if three amino acids are already present on the P side and a new amino acid will come and join at the A side, now there is a formation of bond, and this is between the amino acids on the P side and amino acids on the A side. This bond is called as peptide bond. Peptide bond. Okay, so peptide bond is formed between the amino acids of P side and then amino acids of A side. Okay, now after the bond is formed, now there will be shift of the amino acids present in the P side to the A side. Okay, 1, 2, 3, this is 4. So next, after shifting amino acid from P side to A side, it looks somewhat like this. Okay, but the problem is the tRNA brings the new code and it wants to attach only at the A side. So A side should be free. So what happens now is the entire amino acids present on the A side, acceptor sides, will shift to the P side. Okay, it will shift to the P side. This is called as translocation. Okay, so this is called as translocation, shifting from A side to P side. Entire amino acid chain is shifted here, so that the A side is again free to take up the new amino acid. Okay, so this is general process, translocation process, through which the protein synthesis occurs. Okay, so now we will just see what are the different mechanisms of actions of the drugs in this protein synthesis inhibition group. So first we will see what drugs will inhibit the attachment of tRNA at A site. So tRNA brings the new amino acid, but what drugs will prevent the tRNA, attachment of tRNA to the A site? Yes, this is finished for you. Oh, yeah, it is tetracycline. So it is tetracycline. Now, first is this one. Next one, peptide bond inhibition. So what drug will cause inhibition of peptide bond formation between the P site and A site amino acids? Yes, even this is finished for you. Even this is a broad spectrum antibiotic. It is chloramphenicol. Okay, this is chloramphenicol. Chloramphenicol prevents the formation of peptide bond between the amino acids attached at P site and A site. Okay, now what group of drugs will prevent the translocation process? Next is inhibition of translocation. So what group of drugs prevent this inhibition of translocation? Okay, now this we can remember with a mnemonic MCQ. Okay, MCQ. M is for our macrolides, which we are going to discuss shortly. We will start discussing on macrolides shortly. So first is macrolides. Okay, and then next is your clindamycin, which comes in lincosamides. Okay, and next is quinapristine. Okay, this is streptogram. It will be discussed in the next class. Streptograms. Okay, so these are the various drugs which act through these mechanisms. And yesterday Yesterday we have finished a group of drug, that is aminoglycosides. So hope you know how aminoglycosides act. Aminoglycosides, they act by causing misreading of codons. Misreading of codons. The codes are misread. You know how normally it happens is, for example, we have A, U, G, adenine, uracil and guanosine. So generally the complementary pairs are cytosine. For this it is adenine. For uracil it is adenine. Okay, adenine it is uracil. Okay. For guanine it is cytosine. Okay. So these are the normal correct complementary pairs for these things. But what happens is, when you give aminoglycosides, instead of A and U pairing up, it will be A and C or something like that. Okay, and U and G, something like that. So all the pairing will be wrong. So there will be ultimately a wrong protein formation, and this wrong protein formation will cause the bacteria to lyse. And aminoglycoside group of drugs are bactericidal drugs. Okay, they kill the bacteria by forming the wrong proteins. So these are bactericidal drugs, whereas the drugs which we will discuss shortly, that is aminoglycosides and lincosamides, these are bacteriostatic drugs. Okay, so hope you understood the mechanism of protein synthesis and where all the drugs act and stop the protein synthesis. Okay.